This video is going to center on graphs where the sign chart is not just alternating like they all seem to have been up until now. Here's a polynomial equation. And if I make a sign chart for a polynomial equation, I get that. Now, if I put a really big positive number in, everything's going to be positive. But if I put something in that's between 2 and -4, what happens is that x minus 2 becomes negative, but then it gets squared, so it becomes positive again, so it's still positive. But when I put something really small in, less than -4, this becomes negative. This thing is also negative, but it's squared, so it becomes positive. Positive times negative is negative. And what you find in these sign charts is that anytime there's an even exponent, the sign does not switch. So if I start from the far right, I get a plus there because if I put a big enough number in, everything's positive. But then I get to this 2 here, and since x minus 2 has an even exponent, I don't switch, I leave it. But then I get over here, and since this has an odd exponent, I do switch it. So this is the sign chart, minus, plus, plus, and that would be true for any even number here and odd number over there. That's a polynomial graph, so 2 and -4. And it's useful to get the y-intercept, which is actually pretty high. If I put 0 in, I get 4, so I get 16. It's too high for me to draw. But we get the idea, at least, that this is what happens. It's under, it's over, it touches the graph at that 0, and then pops right back up. So that's how you can have sign charts that don't alternate if there's an even exponent involved on one of the factors. Now let's apply this to rational functions. So y equals x plus 4 over x minus 2 squared. So we make our sign chart with -4 and 2. This is undefined. This is 0. All the way on the right, for a really big positive value, everything's positive. But because this 2 has an even exponent, the sign does not change. But this 4 has an odd exponent, so the sign does change. Now I can draw in my -4, my 0 at -4, and my asymptote at 2. And I like to go near the asymptote. There's a plus u plus. That's like that. Also, since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote at y equals 0. And this plus here means that this thing's going on, and the minus here means that it's going towards the asymptote. And it's useful to get 0, 4 on top, 4 on the bottom, 0, 1. And when I put it all together, I get something like that. And this needs to go through, which is good because it needs to be going up towards it. And there's an example with repeated factors. Here's one where the degrees on the top and the bottom are equal. So the horizontal asymptote is at y equals, if I actually multiply this out, it would be 1x squared and 1x squared. So y equals 1 is the horizontal asymptote. Y-intercept's useful. -3 over 4. And the sign chart is really useful. -3, 1, 2. Plus, the -2 has a squared, so it's still plus, but these both have odd exponents, so it starts to alternate. This gets a 0 and a 0 because they're in the numerator, and a u in the denominator. So we have one asymptote at 2. Have a couple of x-intercepts, one at -3 and one at 1. Also useful, next to this u we have plus u plus. That means we have this thing going on and that. This plus here suggests that it probably goes like that. And this plus here means it probably goes like that, although there is a chance it crosses the asymptote if it's a horizontal asymptote. Actually, we're going to know that for sure because we'll calculate out. Well, from one thing we can see that it definitely goes through the horizontal asymptote in order to get from here to here. Remember that -3/4? That's useful. So here's what seems to be going on. If I really want to make sure that it doesn't cross the horizontal asymptote another time, I can take this equation, x plus 3, x minus 1 over x minus 2 squared, and set it equal to 1. So x squared plus 2x minus 3 equals x squared minus 4x plus 4. Those cancel out. I get 6x equals 7, or x equals 7 over 6. So this is the one and only place that it crosses the axis at 7 over 6, and it doesn't cross it anywhere else. We don't have to worry about it doing that kind of thing. A question I think is interesting is if you're given a sign chart, or given a graph for that matter, to go backwards and create an equation for it. So what you do is where the, this is a 0 here, where the zeros are, that's where you put it into the numerator. Where the u is, that's where you put it into the denominator. And now we look for whether the sign changes or not. Now, going from right to left, minus, the sign didn't change at the 5, so I need an even exponent there. But from this minus to this plus, the sign does change. And from this plus to this plus, the sign doesn't change. But there's one more consideration. Normally we have a plus all the way at the end. So the way we deal with that is just throw a minus in front of here, and that causes all the signs to flip. This is also what you would do if you actually had whatever complicated picture. You could turn it into a sign chart and then turn it into the equation.